Get in position, ready, begin. Okay. Thanks a lot for showing up. My name is Michael Theis. I'm going to tell you, well, it's a, actually I wasn't sure if this is the right conference to present such heavy loaded technical topic. But first of all, I would like to thank the TechIT conference team for having me and for organizing this huge event. In my opinion, they did an amazing job. Thanks a lot for that. Okay, my name is Michael Theis. I'm with MSG Systems in Germany. I'm working for the Automotive Technology department. Actually, I consider myself a C3 architect, which means cloud, chaos, and communication. Uncertified. I don't own any certificate for stuff that I'm telling here. So, well, okay. Why cloud, chaos, and communication? 3 years ago, I started to turn cloud and public cloud in particular, because I think this is the way to go for the future, and this is the way that this is the path that all our customers are following right now. The big car manufacturers in Germany, they all started with, let's say, on-premise clouds. They all started with cloud platforms, and soon they discovered. By the way, who was at the Audi Connect talk? Okay, so there are a lot of challenges to classic, let's say, operations regarding devices which are going to send huge amounts of data across the network, which is something that you're not going to be able to handle with a classic approach. So all car manufacturers in Germany are pushing towards the hyperscale providers, so AWS, Azure, not Google, because Google isn't as important as the other ones in Germany. Okay, so cloud, chaos. If you go to the cloud, if you go, let's say massively heavy distributed systems, you are going to face some lack of chaos, because you're leaving the area of deterministic systems. You cannot predict the future. You cannot predict the behavior precisely of your system. So you have to deal with chaos. And communication, this is the last one. Communication is important to me because I'm convinced that technology is not the only success factor for a project or a product. You need people to communicate properly, and this is why I'm getting into communication as well. Okay, that's, I just added my, let's say, internet or net identities as well. So if you have questions after this after this talk, or anyway would like to keep in touch with me, here are my, let's say, social identities, okay? Why I'm talking about Terraform and cloud infrastructures in general. 2 years ago, or almost 3 years ago, when we started our own, let's say, internal cloud project, I soon started to realize that cloud infrastructures, managing cloud infrastructures is not an easy job. Who agrees? By the way, who actually is working with a public cloud provider? Okay, so I think you all will agree it's not easy, because you have, especially if you're coming from a classical developer role or developer position, you have to acquire new skills regarding networks, CIDR ranges, firewalls. You have to learn Linux. Well, I'm not a particular Linux fan, but again, you have to get used to all these old Linux and Unix style tools, editors, shells, shell scripts, and stuff like that. So it's pretty hard if you want to get into this into this kind of business. And let me show an example. For example, if you go to AWS and you would like to set up only the platform, only some kind of reference network that you're going to deploy your stuff into, okay? You start with an AWS cloud, okay, you should have an AWS account. Then there's a region. A region is some kind of area, let's say Eurocentral 1, which is Frankfurt in Germany. Then you have 3 availability zones, which are separate data centers. Then you're going to have a VPC, which is your own private network. You have an internet gateway, otherwise you cannot talk to your network. You need subnets. And a good approach is to break down your large VPC into dedicated subnets for particular purposes. So you're going to have a web layer, which is an internet-facing subnet, which contains public IP addresses that you can reach from the internet. But this is not the place where you would put your applications. You would put your applications in private subnets, which are not accessible by the internet. Okay? Just for security reasons. So this, well, this, you might say, oh, this is easy, what's the problem? But I would like to note this here. These are CIDR ranges. You have attached CIDR ranges, which means IP address ranges to your network. And you have to recalculate all these sub-CIDR ranges for the subnets that you're going to create. What you want to have is always span your private network all availability zones for availability reasons. So if one availability zone is lost, you don't lose all your running applications or your running systems. So you distribute across all these availability zones. And this is pretty hard to get the IP ranges right. Well, it's hard for me, okay? Because I'm not a network guy. So, then you need route tables and NAT gateways, because if anything is running here in the private subnets, the virtual machines running in the private subnets still have to reach the internet. But you don't want to expose the private IPs to the internet, so you're sending the traffic to the internet through a NAT gateway, which is performing network address translation. Okay? So you have route tables. These route tables route right to the internet. All public subnets route right to the internet. All private subnets route all internet-facing traffic through the NAT gateways, and on and on. Then you have Bastion instances, which a Bastion server, or Bastion server is a server you need to jump into your network because you don't want to expose anything not everything running in your network to the internet. Okay, so you need some sort of jump boxes to jump into the internet. So this is the stuff you should set up before you deploy anything to AWS. So if you're going to use the AWS Web Console, any guesses how long it takes you to set up this network? An hour. You need an hour if you know what you're doing. Okay? So tearing down, it's easy. You just enter delete VPC. Okay? But setting this up takes an hour. So it's not a good idea to do this manually because it's cumbersome, it takes long period of time, it's error prone, and most important, it's not reproducible. Okay? Because you might introduce some errors. Now, so what you're going to do if you need to set up and tear down your networks and all stuff which is running in your network, let's say at least once a day. Doesn't make sense. I'll address CloudFormation later, okay? So, use an infrastructure code tool to automate your infrastructure from day one. This is mandatory. This is very important. And this is something that recommend to every team starting to get into the public cloud, okay? So, what are requirements for infrastructure code as code tool? Well, we had the term opinionated. This is an opinionated view, okay? You need to set up and changing infrastructure, and the process must be reproducible. So if you run the same script or the same tool again, you need to come up with the same network like before, okay? So that means reproducible. You must be able to perform non-destructive changes if you have existing infrastructure. Meaning, for example, if you add another subnet, you don't want to tear down the whole network and start from scratch. You want to update the existing infrastructure and simply add a new subnet. Okay? You need some stuff like if you have a tool that manages the infrastructure, this tool needs to keep some meta information or state about the infrastructure it manages. And this state should be shareable. Because if you have, let's say you are working in a distributed team and different members of the team on different locations are running the same tool or trying to change the infrastructure at the same point in time, you want to make sure that the state information actually reflects the infrastructure which is present in the cloud. Okay, so need shareable state. You want to have dry run support, which means that you have the possibility to, let's say, run a test, run a plan. You generate an execution plan about the changes, and you can review the plan before you actually apply it. Okay, this is mandatory because sometimes the tool could decide this is a destructive change and tears down all the infrastructure without noticing you before. So it's mandatory to have this review possibility. And you would like to have multi-cloud provider support. Okay, these are, from my point of view, the essential requirements for an infrastructure as code tool. So here's a short list of some, well, opinionated, from my point of view, relevant infrastructure as code tools, which are, if you're on AWS, you can use CloudFormation, which is the proprietary infrastructure as code tool from AWS. You can use, if you are going to Azure, you can use resource manager templates. If you want to have, let's say, multi-cloud provider support, or you want to avoid vendor lock-in, you will likely choose one of the Hashicorp tools, Terraform. Packer is not an actually really cloud infrastructure management tool, but I will show you what Packer does in 5 minutes, okay? So Terraform is, you can use, the big plus with Terraform is you could use the same tool for multiple clouds. Okay? Not with the same script, but you can use the same tool, which is a big advantage compared to using the proprietary solutions like CloudFormation or Resource Manager templates. And last but not least is Red Hat Ansible. I would like to perform a short survey. Please, hands up, who uses CloudFormation? 1. Who uses Azure Resource Manager templates? 3. Who uses Terraform? Almost the same, 3. Packer? Okay, 1. Ansible? Okay, 2. Great. Well, I'm going to focus on Terraform and Packer today. So let's start getting into Terraform. Okay, Terraform Essentials. Well, it's a tool by Hashicorp, and it's open source. It's simple to install or to download. So you simply download and run it. It has a huge active community, working very close to the cloud providers. So if let's say there's a new AWS feature coming up, there will be pull requests for the support of this new feature within some days. Okay, so they're very close to the actual clouds, to the capabilities of the actual cloud. It's an easy to learn DSL called HCL, Hashicorp Configuration Language. Well, if it's easy to learn, that's up to you, because I'm going to show you some code later. Okay. It supports all public cloud providers. It has a separate plan and apply phase. This is the point where you can, in the plan phase, you can review. With the apply phase, you actually run your execution plan. Okay. And a very important thing is, if you have complex infrastructures, you will need to encapsulate, let's say, certain patterns into modules, and Hashicorp Terraform supports this. Okay, you can write modules, for example, for setting up a reference network, and you can reuse it in your projects. And it's simple, as I told you before. Okay, these modules can be shared very easily using the file system or Git repositories or Terraform registry. So it's easy to share these modules. Here are the most important Terraform commands. You simply run a Terraform init to set up a workspace. A workspace is nothing less, it's simply a directory, a folder. Okay, you change it to the folder, run Terraform init, and Terraform sets up this directory as a Terraform workspace. If you want to check your Terraform scripts before running them, you can use Terraform validate. If you want to run the plan phase, you can enter Terraform plan, which means Terraform generates an execution plan and shows you what it's going to do. And in the apply phase, you're actually going to execute the execution plan. Okay? And with Terraform destroy, you simply tear down all the infrastructure that you set up previously using Terraform apply. Any questions so far? Okay, how does Terraform work? You will find several files in the Terraform workspace, in the Terraform folder. Usually the convention is you have one main TF file, which is, let's say, the entry point of your Terraform module or your Terraform project. You can add various other Terraform files in the same directory. Terraform simply merges them into one and executes them as one. Okay? So then you would, in most cases, you want to have your scripts parameterized, so you can add variables that you can pass to your script. And in most cases, you want to have some outputs meaning that Terraform should display some IDs of networks that it created or stuff that it created. Okay? So, just 2 more slides about the concepts. As I told you before, you can share common infrastructure patterns in a Terraform module, and this Terraform module can be shared via file system, Git repository, Terraform registry, a simple web server, or an S3 bucket. And all the blob stores on Google are supported as well. Okay? So, but you have to be a little bit careful because, well, if you cannot compare the module concept like let's say a class in Java. It's not the same. It's not actually code that is called. It's more like in C. It's like big includes. So the source code actually of the modules gets included into your own source, and then it's simply run as one whole script. There's no actual call, which can lead to some pitfalls. Multi cloud provider support. The important thing is that you cannot use the same script for multiple cloud providers. Doesn't make sense. If you want to address, let's say, Azure, you have an Azure version of your script. And if you want to address AWS, you have to use an AWS version of the script. The reason for this is that the object models of the cloud providers, they simply differ too much. It doesn't make sense to use one canonical object model within Terraform to map it to the cloud provider specific model. Okay, so in your scripts you always use the cloud provider specific model. Okay. And one other topic, I told you about shareable state, because why is it important? Let's say Alice starts to use, checks out a Terraform script from a Git repository, runs it, she gets local state on her machine. Now, Bob, sitting on a different location, is going to run the same script. Maybe he edits the script or passes different variables to it, and he gets his own state locally on his machine. Now the problem is these two states will differ. Okay, so you always should store your state on a remote backend and share it among all team members. Okay, so no local state, use remote state on a remote backend. Any questions so far? Okay, it's demo time. So we can get into this is actually a short test if this is really easy to learn. Each Terraform, well, let's say project or workspace has to start with at least one provider definition. Here, I make sure that I want to create infrastructure on the AWS cloud. So I'm using the AWS object model. Okay. Next thing is Terraform backend S3. I want to store the state when I run Terraform commands, not on my machine, which is the default, but I want to I want to store this Terraform state on a S3 bucket on AWS. Okay, so I can share it. Everyone who is checking out this script will use the same backend. Okay, so the next thing is I want to set up a complex. Okay, here's another feature. I can define local variables, which I use just within my scripts. These are not variables that I pass from the outside. Okay, and here's the way I can use modules. as you can see, usually I would define a module source residing in a Git repository. For demo reasons, I simply refer to the file system. Okay? And here I pass the values for the variables of the module to the module. And this module simply sets up the reference network that I showed you before. Okay? So if we switch to the, oh, this is the wrong one. Let's switch to the, so these are the variables of the module, okay? These variables must match all the parameters that are specified here, okay? And this is the module which sets up, as you can see, it's a little bit more complicated than the other one, okay? So here it creates the network, the subnets, the gateways, the Bastion instance profile, the Bastion servers, and stuff like that. Okay? So, how long is it going to take when I run this in Terraform? Any guesses? This is the same. I'm creating the same network like I showed you before. Any guesses? Okay, let's see. So I'm running Terraform init. I'm running Terraform plan. As you can see, oh, sorry. Okay, there were some lines when Terraform told me that it's going to refresh some state. Terraform is going to check if there's anything existing on the cloud before, okay, of the objects I would like to create. Now it's going to list everything that it's going to create or change or to destroy. There are changes which are destructive. For example, if you change the image of a virtual machine, this virtual machine needs to be destroyed and recreated. Okay? So there's no way to run this without tearing down the... So to make things easier, because Terraform is going to ask me again if I really want to do this, but I'm going to suppress this and say, okay, I reviewed the plan, please execute the plan. Now it's running the plan phase again, okay? It's pulling all data from the cloud. So now it's starting to create. Okay, it's done. So if you switch to the console, here's my network with the complete reference structure built. Okay. Any questions so far? Okay. Now, this is a short glimpse on Terraform. Sorry, due to time reasons, I cannot dive deep further or drill deeper. We have to remain scratching the surface. There's another topic I would like to mention, another tool that's, from my point of view, it's important, which is called Packer. Packer is a tool to build virtual image, to build files representing virtual machine images. So for example, if you would like to have, and this is a common use case in AWS, when I started moving to AWS, I wanted to use CentOS as a operating system for my virtual images, and guess what? There's no free CentOS on AWS. You can have Ubuntu, you can have Fedora, but there's no free CentOS. There is a commercial CentOS where I have to buy a subscription. So luckily, Packer allows me to add my own images to the public cloud, the public AWS cloud. And this I can do with Packer. Again, Packer is an open source tool by Hashicorp. It's supposed to build identical VM images from a single source. So if you run the build again, it's producing the same image. You can, let's say you can create and upload images from scratch to AWS, or you can extend or modify existing virtual machine images on AWS. Okay? It works well with other well-known configuration management tools like Chef, Puppet, and Ansible. The way it works is Packer starts a virtual machine. Then it uses the tool that you would like to use to configure this virtual machine. And then it stops the virtual machine and exports it to a certain file format that you specified. Okay? It works for various VM platforms, Armies for AWS, VHD for Azure VMs, OVF for VirtualBox. Actually, I'm using VirtualBox to build the local VirtualBox to build the CentOS image file I'm going to upload to AWS. It uses JSON as domain, as DSL, which is something I don't like, but well, that's the way Packer works. Let's skip this. Okay, you have three commands that you have to keep in mind. Packer build means it runs a build, it builds a virtual machine image. Packer validate validates a template, which is some kind of Packer script, JSON document that you add to Packer. And you could use Packer inspect to validate your templates. Okay? So let's switch to Packer. Short demo. Okay. This is a Packer template to create an virtual machine image for AWS called AMI. Here, this is a builder which takes a virtualbox in an ISO file. Here's a name for the image, the download source for the ISO file, the SSH user Packer uses to connect to the virtual image. Here's some stuff to set up the virtual image, to run the installation of the virtual image. And here's another thing. So what this builder would do is it simply converts an ISO file into an OVA file, so which is uploadable to AWS, which is a virtual image file format supported by AWS. So Packer has this concept of post-processor. So post-processor takes the existing build result and transforms it into another artifact. In this case, it's doing an upload to S3 and a virtual machine import on AWS, so that this OVA file is actually imported as an AMI into AWS. Okay? Unfortunately, I cannot demonstrate this because this runs definitely about 15 minutes, okay? But I think you get the concept of this. So let's look at some common use cases and how to solve them with Terraform and Packer. Again, actually these slides are from my training sessions about infrastructure as code. So, but I'm going to focus on AWS. So all samples are for AWS, but it's all, what I'm showing you is possible with Azure as well. Okay, so the first thing is add new VM images. The second thing is extend existing VM images. The third is create reference networks to host further infrastructure. Provision a Kubernetes container service instance, which means I don't like to set up my own Kubernetes cluster. I would like to use EKS as a pre-packaged Kubernetes cluster, okay? And the last one is build your own Kubernetes cluster. Well, I'm not sure regarding time. I think we have 5 minutes left before we, 10 minutes left before we start discussions. Is there anything you would like to know in particular that you're interested in? You're still with me, right? Okay. Good question. Well, from my point of view, it's, well, I don't care about the actual public cloud provider, personally. And all our customers are using both. So it's important that you have a strategy or support for both public cloud providers. Well, AWS is, well, it's a technical leader. It's still ahead. Azure is the closest competitor, but it's still lacking some, well, I would say AWS is the more reliable platform. That doesn't mean that Azure is not enterprise ready, but AWS is the best provider if you, from an enterprise perspective, because the training material is excellent, the support is excellent, and this is something that Azure is trying to, they have to get better there, okay, on this topic. No, and the point is all our customers, if you're a big customer, you don't use the regular price lists. You have some volume contracts with all the providers. So actually the prices don't differ that much, okay? So, well, maybe I'm going to get right into actually, I would so this is what we did, okay? So let's see what it means to set up a Kubernetes container service instance with Terraform. Again, this is something, it wouldn't take 1 hour to do this using the web console. But let's say 20 minutes, 30 minutes, but that's not the point here. If you run this with Terraform, it will take 50 minutes, about 50 minutes. But this is not due to some constraints with Terraform. This is the reason for this is that starting a Kubernetes cluster as a service takes almost 10 to 15 minutes to run. Okay, until it's available. So what we have to do here is set up, well, this is a simplified picture, okay? Imagine this is the reference network that I showed you before, okay? So now I'm going to instantiate as an Amazon Elastic Container Service for Kubernetes. the funny thing is about the Kubernetes cluster that you will get is it's only the master nodes. So only the administration part of the cluster is running. Okay. Now you have to add workers where your workload is running on. And this is done by using an autoscaling group. Autoscaling group means, let's say, I want to have 6 instances running on at any time. So this autoscaling group makes sure that these instances are always running. If one crashes, it starts another one. Okay, and you could use it, this autoscaling group, to add some, let's say, metrics. Or some, let's say, some rules. So let's say if a CPU consumption on one of these worker nodes is higher than 80% for 1 minute, it will start another machine. This only works because actually there's nothing to install on these machines, because these machines are based on pre-built AMIs. Okay, so you simply have to start the machine. Everything is pre-built with Packer. The AWS guys use Packer as well. Anything is pre-built with Packer, so you simply start up a new machine, and the new machine joins the cluster. Okay. How would this look like? Let's see. Actually, this is a module. This is a Terraform module which sets up an AKS cluster plus autoscaling group for your worker nodes. Okay, so what you can see here is here I used these multiple script files approach. Okay, so I split my Terraform script into various TF files. Okay, so there's one entry point, one to create the master group, to set up the AKS instance, one regarding roles, which is security stuff. What is the virtual machine in the master group allowed to do? I have security groups, which are sort of virtual firewalls that are set up. I have variables again. VPC is creating a network for this cluster, and I have a worker group and worker IAM roles to set up the worker group, the worker instances. Okay. Well, just okay. Regarding the capabilities of Terraform, there's one strange thing that you have to do when you set up an AWS AKS cluster, which means you have to start the master group, and then you have to perform actually something into the cluster before the workers can join the cluster, which is pretty weird, right? So you have actually you have to perform a Kubernetes deployment, and the fun thing is Terraform has a Kubernetes provider which allows you to run to create Kubernetes resources in a running cluster, which you shouldn't do outside this context. Okay, use Helm or any other tool to deploy stuff to your cluster. Yeah, but in this case, we can use the Kubernetes cluster to deploy a config map to the cluster, which actually allows the workers to join the cluster. So you create the master group, deploy the config map to the master group, and then you set up your workers that they can join the cluster. Okay? Any questions so far? Oh boy. It's getting late. Huh? Okay. Unfortunately, I cannot show you anything. It doesn't make sense because it will run for 15 minutes. You just see some lines scrolling. It doesn't make sense to show you. But the good thing is, this is foolproof. Okay, it's reliable. You always produce the same cluster that you would like to have, simply by running these tools. The other good thing is you don't have to do this manually. Actually, you could write a Jenkins job or whatever CI tool you would like to you prefer. You could simply a job which is running Terraform, running your script, and you create Kubernetes clusters simply by running a Jenkins job, for example. So it's very easy to set up infrastructure for a specific purpose, for a specific period of time, and then you simply tear it down. Okay, and you can fully automate this process with Terraform, for example. Yeah.
The workers, why would we need many number 6 workers or many or less than that? And what kind of services does that Kubernetes stuff provide?
So the question, okay. Well, this is actually, I didn't want to get into Kubernetes because this is not related to Terraform. But okay, the master group is just responsible for keep the cluster up and running. Okay, the workers are meant to execute or run your applications, which are Docker containers. Okay, so what Kubernetes does is it's doing all the orchestration part. So it makes sure, for example, that if your Docker container, which is running on this worker instance, if the container crashes, it's resurrected, it's restarted. Okay, you have stuff like less elasticity. So if you want, let's say you're running three instances of the Docker containers, which are called pods in Kubernetes speak, okay? And three instances are not enough. You can, again, since version 1.14, you can have something like auto-scaling. Okay, so if 3 instances are not enough, you can, let's say, start another 3 instances. And Kubernetes makes sure that they're all properly distributed across the worker instances. So it's mainly for availability reasons, security reasons, and stuff like that. Okay? But this is out of scope of Terraform. It's a Kubernetes topic. Okay? And
having 3 Docker instances, would that mean that your application is deployed 3 times, or I don't get it?
Yeah. We have 3 instances, and the good thing is that Kubernetes treats all these instances as one logical service. You have one name to access your application, and Kubernetes does all the load balancing and routing stuff.
Okay, and then the data, so the data source would be the same for the 3 instances, or how would you manage?
This is something, this is up to your own. Normally you would use one database for all instances. Okay.
Okay, thank you.
Okay. Okay, so I think I'm going to wrap it up. Well, so I hope I gave you the right message, which is you need an infrastructure as code tool if you're going to public clouds, okay? Because it's very important that you that you're able to set up your infrastructure very fast, reliable, and reproducible. Okay? Another thing is you always should prefer to pre-build images, virtual machine images, rather than run a bunch of virtual machines and then, let's say, run Ansible to configure these virtual machines or install stuff on these virtual machines. Use Packer to build pre-built images. Okay. Another thing is you should focus on the manual tasks that you do very often. It doesn't make sense to automate anything, everything. Let's say if you have something that you're doing once a year, it's pretty okay that you keep this simple task manual. Doesn't make sense to invest in automating it. Okay. So another thing is, well, I showed you Terraform. If you're happy with CloudFormation, it's fine. If you're happy with Ansible, it's fine. If you're happy with resource manager templates, it's fine. But please use one tool. Okay? Don't use the console. Okay? And another thing is, Terraform is no silver bullet. Yeah. For example, sometimes you have to, let's say, set up certain infrastructure with Terraform, and then you use another tool to install some stuff on these virtual machines. Okay? So it doesn't make sense to try to use Terraform for everything. Okay? So, thank you for your time. Almost done. Any final questions?
I have a question.
Sergio, louder!
Wait a second. I'll give you the mic. So you told us that we always use some kind of architecture as code, but people are usually more familiar with. I'm not used to this. People are more familiar to use the GUI, so interface to click around.
Yeah.
Are there like ready to deploy or templates for Terraform or some out-of-the-box solutions, and you just customize those?
Yeah. That's what I told you about modules. Actually, there's a global Terraform registry where you can find Terraform modules for almost anything that you would like to do. So there's a community which is actually providing you with modules for common tasks. Yeah. Well, you have to make sure that this module actually is the right one for you. Okay, but
yes, but at least you have a starting point.
Yeah, sure.
Because I'm just thinking about something more basic like Jenkins. We switch from basic Jenkins builds to Jenkins files and pipelines, and there were tools that you have had to configure Jenkins the normal way, and that generated your Jenkins file, or at least build step for the Jenkins files, and you just could insert that.
Actually, Audi Connect is using the same approach with Terraform. They have some proprietary configuration file format, and this will create Terraform scripts for you and run these scripts to build infrastructure on AWS. But personally, I don't like this approach. I mean, Terraform is not, the harder part is to get to know the infrastructure of your cloud provider, the object model, the resource model of your cloud provider. That's the harder part. Programming it with Terraform, it's not that hard. Okay.
Thank you.
And not everyone has to do it. But Unfortunately, we're turning into a DevOps company, and our customers are going to want us to set up infrastructure on the public cloud. So we need to get into stuff like that. Any more questions?
I think we are also out of time and a bit late. So if you want to ask Mike questions, I'm pretty sure he will be available.
Yeah, I'm available here. Again,
networking.
here are my contact data. So thanks a lot.
Thank you very much.
Thanks for having me.